Hi, Simeon. Can you
Hey,
see my
go
screen?
ahead.
Hello,
I
everyone.
can.
Hey, thank you. Well, my name is Peter Bechet. Worked with Crosslake, and I've been working for Mojaloop mostly around the performance for the last 4 or 5 years. I'm now presenting the effort that the vNext team has been putting. So let me start with an agenda. We're going to discuss the introduction, the typical introduction. We're going to go to the progress update, a demo, and then some next steps at the end. So what is Mojaloop vNext? Mojaloop vNext is the implementation of the reference architecture. So in 2020, we did an exercise called reference architecture that designed what good looks like. So in essence, what everyone contributed to was an abstracted design of how the system could be re-equated, refactored around the bounded context approach to have the maximum scalability, maintainability, adaptability for the next generation, for the future of Mojaloop. What it means is that from the outside, it's exactly the same thing. So it's a different architecture. It has been built in parallel. As you know, the name we got for it is vNext, not probably the best name, but that's the name that stuck. So as I was saying, it's exactly the same feature set. And whenever we release this as an official version, it will probably be V20, or we don't know the number for that. And as I mentioned, the most important thing to capture is from the outside, it is exactly the same. So it's exactly the same implementation API, FSPIOP, version 1.1 that we currently have running in the current version of the code, V15. Inside is significantly different, is very different. So it's like we've recreated it from inside, but from the outside, it looks exactly the same, which is the contract that we have with the FSPs. So when we release it, it will have a standard upgrade mechanism so that people can be able to upgrade and start working on custom upgrades whenever this is released. This is the bounded context approach. And I'm not going to explain this again, but this makes a lot more sense when you know the current approach that we have, and because it shows how significantly different this is. So what we did here was we split pretty much all of the different components of the system in their own bounded context. And each of the bounded context solves one problem really well, but has no idea about the rest of the system. So the way they communicate with each other is through known and stable interfaces, and they do some part of the function of the whole switch really well in isolation, so they don't know what's happening on the outside. They react to API calls and they react to messages. They produce messages as a consequence of doing work. The big benefit of this, or one of the big benefits of doing this, besides scalability and resiliency, is that code gets much simpler. The downside is it's really difficult to design a system like this, but on the positive side, that's what we did in the reference architecture exercise 3 years ago. So this design allows us to work, for example, in transfers as a developer, in enhanced transfers without knowing what's happening in the participants, or without knowing how the accounts and balances, how the ledger actually runs. Is it running Tiger Beetle? Is it running something else? How are settlements being performed? We don't care. As a developer, we have a code base. Every time that we tackle a problem, that code base is much smaller, much cleaner, much simpler to understand. And that's the consequence of this design around the bounded context approach. So I'm not going to go much more through this. And what is the update on this? We've been working. We did a big demo back in March at the end of PI 20. And we showed pretty much all of the main functions of the switch working with the happy path. So what was done was all of the perfect condition features and use cases were working, and we demoed that to everyone in the community. What we've been focusing on in PI 21 has been the non-happy path. And as curious as it might seem, the non-happy path is actually a lot more work than the happy path. Obviously, getting to the point where the happy path was working was a lot of frameworking and a lot of groundwork that had to be put in. The actual work to have a transfer working flawlessly when the inputs are impeccable, it's not much comparing to the work that is required to cater for all of the non-happy paths that we have built in and all of the failure conditions that we have in Mojaloop. So that's the most important thing. That's probably the single bit of work that has been taken more effort from the team. We've also been doing settlements enhancements. Some of the stuff Jason mentioned it. We've implemented net debit cap. And the other big chunk that has been going in terms of effort, big chunk of effort, is the test coverage. So we now have a much more increased test coverage in our code base. It's still an alpha, so mind you that it's not a released version. It's not an official version, but it's going in the right direction. We're also integrating test coverage and test scenarios and tests all through the CI/CD pipelines, and we would like to demo in the next PI the full pipeline from changing code to deploying code in a test environment. Right now, we're only missing the deploying to the test environment. Everything else is already working. And obviously, we've been focusing on getting the alpha the alpha version released, which is what we're going to do in a couple of slides. So in terms of business main use cases, this was a bit yellow last time I showed. Now it's all green. So the onboarding is done. The lookup, it's done, including bulk. The quoting single and bulk is working. The clearing is working. We don't yet have bulk transfers, but we do have single transfers. Settlements, we are now able to generate the allocation, able to query, able to have the settlement batches and execute the settlement of a matrix. And most important, which was the part that was missing since the last demo that we did, we're now able to update the accounts at the end of settling or the settlement process. Accounts and balances, it's in the same status. That's pretty much because it was stable before. It works with either Tiger Beetle or the built-in ledger. So that's complete. In terms of cross-cutting concerns, and cross-cutting concerns, just for those who are not familiar with the term, these are the features that are not necessarily the most important things that Mojaloop Switch does, but they are certainly supporting features or features that are required for the important things like clearing and lookup and settlement to happen. So authentication, this is still the same case. It was done before. This was a fundamental part of our platform. The platform configuration, also, we now have platform configuration a bit more evolved. It allows us to do changes in the configuration of the switch without redeploying. So effectively, what I'm talking about is as a hub operator, I'm now able to go to the UI, to the administrator UI, or to the API. It's the same effect, and do a change in a configuration, and all of the services will be notified that there's a change in the configuration for the system that might affect them or not, and they are able to reload their configuration and keep on working with the new settings. This is a significantly important portion of what we're doing because it allows changes to be done. Obviously, this is not for all changes, but it allows changes that to not require a full redeployment of the platform. Auditing, that was done already. We have a dual stage enveloping and cryptographic signature applied, where the auditor component, the auditing component signs the message, sends the message to the central auditing service. That one verifies the signature, wraps it around a new signature, and then deposits that in a really read-only store. That means that we can later prove that there was no tamper with the auditing. The logging, same principle, minus the security concerns. Obviously, so logging is for developers. It's less critical. The admin APIs in the UI, we're still working on those things. The onboarding lookups, pretty much all of the foundational part, that's done. But there's some enhancements that we still need to work on. So I usually like showing this slide, and I don't want you to read. That's probably very difficult to read, but My intention here is that you can notice, or if you notice the previous presentation, you will notice that there's a lot more green faces than there were before. There used to be a time when all of this was either had no face at all or was just an orange face, and most faces are green now. That means that we have these blocks of functionality from the reference architecture. This is taken directly from the reference architecture diagrams. These blocks are already working. So we have the main use cases working, and in most cases, the non-happy path and the non-principal use cases working as well. All right. So with that, I'm going to go to a live demo. I'm going to stop sharing and change. And give me just a second, because I will need to change to another screen. And this is really a live demo. So all of the consequences apply. I hope everything goes smoothly. Can you guys see my screen? I'm sharing a browser.
Yes, we can through the browser.
All right, thank you. So this is the Mojaloop vNext admin UI. There is a reason for us to create an admin UI. Obviously, Mojaloop is mostly around APIs. The fact that we have a UI started, or the reason for having a UI started at the beginning of our development journey, it was difficult for us as developers to see what was happening in the switch. So we decided, let's get a very simple, even if very ugly, UI that we can use to call the API, so that we don't have to spend so much time in databases and sending API calls in Postman. So this is how this was born. Turns out it's actually very useful for an operator. So what you're about to see is a demo of some of the latest features that we have been including in Mojaloop vNext. So what we have here is this is the entry point. I'm going to show this page. This is the green bank. Obviously, we're not very original with names, and we keep using the same ones. And green bank has a liquidity account or settlement account of 3,000 euros. That means that it has 3,000 euros in liquidity. I'm going to show you the blue bank, and the blue bank has 1,000 euros in liquidity. This is the famous TTK that we are using. The one in blue is representing blue bank. The one in green is representing green bank, as obvious. So what I'm going to do now is I'm going to set the green bank's net debit cap. So to that purpose, I'm going to create a net debit cap, and I'm going to say, I want the net debit cap for the green bank for the euros account to be 50%. As usual, we have maker checker. So that means that I will not be able to approve this. If I try to approve with the same user, I'm going to be denied. So what I have to do is I have to log in and re-log in with another user. Don't mind the name of the user. It doesn't matter if it's administrator or not, because users have privileges and have roles. So there's no admin user that can do everything, and the user does less than that. So it's just the names that we have in development. So when I'm now back at the green bank, I have this request. I'm going to be able to approve. And as I approve the request, the net debit cap change, it gets calculated to a fixed amount. So what this means is that I have a net debit cap of 50%. The liquidity at the time of setting the net debit cap was 3,000. That means that my amount that my net debit cap now is 1,500. So this is nothing changed in the account. Let me now try to show you how we can do a transfer. I'm going to start with a quote. We have these nice screens that allow us to do tests. So I'm going to send 100 euros from the green bank to the blue bank. I'm going to create my quote. The quote was created. As usual, you can see things happening in the TTK because we are using TTK to simulate the DFSPs. Again, I have a test button in here. All of the yellow ones are test buttons. This is my quote. That means that I can pick up this quote and create a test transfer from it. It's exactly the same data. I'm going to create my transfer. Transfer was reserved and then immediately changed to commit. So that obviously is showing the steps that we have. It was prepared. It was then sent to the FSP. So you have all of the steps in here. I showed you this the last time. So This part, it works exactly the same. You see the transfer here going back to the requester, which was the payer at the green bank. So there we have it. We have a transfer. What I'm going to show you now is what is the account status for both participants. So the green bank, it still has 3,000 in liquidity because that won't change until we settle, and it has minus 100. So it now has a shorter position. What about the blue bank? Obviously, it has a positive position of 100, whereas before it had 0. So now what I'm going to do is I'm going to settle. In my transfer, I have this nice feature, and this is not a test, this is a normal feature, that allows me to search for a transfer in the settlement. Because what happens as part of the bounded context and the logic that we have where the different parts of the system work independently through messages was that as we did the transfer, the settlements component, which is the same that Jason explained before, the settlements component picked up that transfer and associated that transfer to a batch, to a settlement batch. And this is the batch it was associated with. You can see the name of the batch. It respects all of the model definition that we had. This is pretty much what we demoed last time and what Jason showed you in those nice graphics. So what do I have here? I have my batch that has that one transfer. There was only one transfer. Because it's a 5-minute batch, I think, 5 minutes haven't passed. So if I create another transfer, it would end up in the same batch. But the intention here is, let me settle. I have two ways of settling. Either I create a dynamic matrix, which is basically saying, I want to settle everything with settlement model.
Pedro.
Yeah.
Can I just ask a quick question? Before you settle, can you show how we can see the liability that has been incurred by one bank over the other?
We don't, yeah. I will do that before. Give me just a second. Well, actually, that's a good point, but that's exactly what happens next. So, as I was saying, I can create a dynamic matrix, which is a matrix that will find batches based on the criteria, a model, a currency, a start and an end date, or I can individually create a static matrix, which is a matrix where I define which exact batches should be in that matrix. That's what I'm going to do now because we didn't show that in the last presentation. And now we have a settlement matrix or report. And this is what Paul was suggesting. That's a good point because I was about to skip that. This is your matrix and it includes this batch. And it also shows the transfers that made it to this settlement matrix. And it shows the position. So this is the positions. This is the responsibilities of both participants. So we have green bank and we have blue bank. Let me show you again the accounts. Nothing changed the accounts except in the position accounts. So the liquidity account didn't change. So what I'm going to do now is I'm going to settle this settlement matrix. So there we are. This settlement matrix is settled. There was no visual cue. That's the stuff that we're still working on it. But we can now, I'm going to refresh this. And you can see that my position is back to 0 and my liquidity on the payer went down 100, which is correct. And on the blue bank, what happened was, again, the position went back to 0 by 100 and the liquidity increased by 100. So at the end of the day now, the blue bank would be able to withdraw 100 more. And there's another thing that happens, which is how does this affect the net debit cap? Well, the net debit cap was supposed to be a percentage. So what happens? I refreshed my page, and what happened was, as a consequence of settling, two things happened. There was a message that was sent and picked up by the participants' side of the system, the participants' bounded context services, that looked at that message and said, there's a settlement that just happened. I will update my liquidity and my position accounts for those payers in that settlement matrix. That's the delta discussion that we were having before in Jason's demo. Those deltas are the ones that we use in the participants to update the positions. There's another thing that happens. Because we have a net debit cap that is defined as a percentage of the liquidity, and the liquidity changed, it triggers another recalculation, which is the net debit cap. So effectively, we now have a new net debit cap value that was recalculated automatically. We don't have to do this. So what?
And Pedro, before you move on, so if this were actually specified as a value, and let's say that trades go against this bank all day long, and eventually their managed balance falls to or below the net debit cap, does the recalculation cycle select a new net debit cap, which is the minimum of the managed balance and the specified amount, or does it simply block the trade? How does that occur?
It just blocks. It simply applies. Right now we have just one net debit cap, which is, you can define it as an absolute number or as a percentage. But
right, but if I specified it, but again, if I specify it, let's say I specified it to be 1,400 and not 50%, but 1,400, then it uses that number. So then what happens is that, say another £100 trade goes against me, it won't work because it would violate that net debit cap. But if a $50 trade went against me, €50, then I would be at that net debit cap. I would find myself right at that limit. Am I getting that correct? That
yes,
it wouldn't
definitely
be recalculating at that point. It's basically just saying, nope, it's a hard limit.
Correct. Let me show you how that works. So right now we have in liquidity, we have 2,900, right? In the green bank, but we do have this net debit cap. So let me try to do another transfer. I'm going to create a quote. I'm going to say that I'm going to send 2,000, which according to my liquidity, I should be able to send.
Right.
I'm going to create my quote. Quote's done. I'm going to create my transfer from the quote. It's taking a bit of time. Oh, wait, sorry. There, it was aborted. So that what just happened, obviously we can look at the logs and you will be able to see in the green, the one that sent this here as insufficient funds. So you have the 4001
brilliant.
Error, which means it couldn't respect. But
that's brilliant.
If I do less, I can do it, obviously, and that's something that I can show. So let me do a bit less. So let me do the math. What can I do? I have 1,400. So I should be able to send 1,400. Yeah. Let me send 1,400. That should work. Here's my.
Because your NDC is 1450, so you've got the full amount.
Correct.
I still have 50.
Yeah, you have 50 left.
There, it's committed. So, and let's show how it looks.
Is there a place in the UI now where I can just go and look and see how much headroom I've got on my NDC?
Good point. Let me take note. That was one of the things.
That's exactly one of the things we would want to see on an operations screen. First, as an overall picture, very high level, but then the ability to drill in and have that stuff available. So usually you have a working monitor that you can point at something that you're trying to study, and you'd want to be able to see that calculated net position, or I should say net liquidity available, which is the balance minus the position.
I think we might be able to put it in this list by choosing the currency. And then when you choose the currency, we will be able to show the participants with the available net liquidity expressed in that currency. The problem, we actually tried to do that, but it ended up multiplying these lines by how many currencies there are registered. Obviously, for a single currency switch, that's never going to be a problem. But
I think I think it comes down to that the API needs to have the ability to select a group of DFSPs by currency and so forth to say, I want to see the current balance stacked with the current position, stacked with the NDC, and be able to show the white space if there is any. And of course, to flag anything that looks like it's inside of kind of an operational, monitoring rule that says they're getting close, somebody should call them. Something like that. So, but the API has that, then somebody can make their operating rules around what the API can serve them. We don't have to do it, but we would have to show examples of how you might use the information. I think it was Rob who said to be able to see like what's my current headroom.
Exactly, and that's a good point. You mentioned a couple of good points there. So I took note. let us.
Brilliant.
That's not too difficult to do. So it's really easy to have an API that does that sort of calculation. So that's not difficult. You mentioned another thing, which is the notification. That's one part that we don't have yet ready in vNext, but it's in the line. It's in line. So it's in the. We know what to do. We've designed it as part of reference architecture, which is the ability for the hub operator to define custom notifications. And one of such custom notifications would be about thresholds. So you would be able to say, if my liquidity goes to 10% of what I defined or a certain number, I want to be reminded of that through an email, a Slack message, whatever. The logic is still the same. We will abstract the transport so that the notification can be pluggable, the notification mechanism.
Yeah.
But
so there's essentially an admin channel to the DFSP where you can send them stuff that they need to know with appropriate priorities. And yeah, sorry about that, James. I got my people wrong here on the reference. That was James's question originally about the head.
Oh, sorry, because I'm not checking the questions. But yeah.
Yeah, no. It was James's initial request. That's fine. This is great. I'm great to see that it's coming together. Thanks.
Yes, that will be there. And a lot more custom notifications will be possible because the way we are implementing this is there's public events that happen, or the events that we are defining as public that reflect what happens inside the switch. An operator will be able to register to those events and trigger some sort of communication that event happened with additional data. So that's going to be very powerful in terms of reducing the amount of manual work that operators need to come to the UI or to the API and see what's happening. They will be notified actively in real time, and that's something that hopefully we can show in the next demo. So, there's my transfer that I just did. Let me show you how this is in terms of position. So again, I'm going to settle this. Let me show you blue. I'm going to settle. Well, let me show a different way of settling. I can go here, I can settle, and I can show all of those. I can create a dynamic matrix, which is all of the batches that I included between start date and end date and respect the default settling model and euros as currency. Again, the same principle applies. I'm going to settle that. There it is. This is settled. Again, I'm going to refresh so that you can see what happens. So now my liquidity for the green bank is now 1,500. That was decreased by 1,400. Blue bank is obviously getting all of that liquidity, and the same thing still happened in the TTK. So this is important. This is so that people don't think that this is magic. This is really happening with the TTK working. And the other thing that happens, as you're probably going to imagine, is the percentage was recalculated. So we now have a new fixed value. So this is the presentation that I had. This is the demo that I had. Let me go back to the any questions that you guys would like me to answer while I'm showing this?
I'm going to ask you to issue a health warning to stop people saying, I want one of these.
I'm not
it's
really
very impressive. It's very impressive.
It's very impressive.
Go back to your big smiley faces and say you don't have all this stuff and the blanks. Just to
I have good news for you in a couple of slides then. Let me stop. Oh. All right, so let me go back to apologies. I need to put this again. Sorry. Presenter's view, because I have a couple of notes. All right. Sorry, I have so many windows open that when I want to share, it takes a while to. You can see my screen again, right?
Yes.
We can.
All right. So a few notes regarding the demo. These test calls and screens are only enabled in development. This is important. Obviously, this will not, whenever you're running a switch in an environment that's not a development or a test or a non-productive environment, those things will not be there because we don't want interfaces to create transfers unless it's in a non-productive environment. So those things will not be there. None of that you're seeing that I used to do tests will be there. Only the read-only views, and obviously you will update the MDC and all of that. So that's an important thing. because this is not a UI to obviously execute any of those changes in the system. So that comes from an API. And by the way, the calls that I made go to the API. So they don't go to a magical internal system. They are actually going to the outside, to the FSP IOP API and doing a normal call. And that in turn goes to the inside of the switch and then comes out again to the TTK. All of what you've seen is exactly as it happened and as it should happen. There's no special demo mechanism. So all of the requests went to the FSP API that we are implementing in vNext version 1.1. And we would like to get started with a POC implementation of the ISO 222 as soon as possible. One of the benefits of the design that we have in Mojaloop vNext is that you can have multiple APIs, because the way the API works and the specifics of the FSP IOP protocol stay on the outside in a layer of APIs. So inside, transfers, participants, ledgers, all of those things have no idea about the protocol details, which means that as long as we can call the internal interfaces with some external mechanism, we can make it work. We don't need to change any of the internals to have a new external API. And that goes to ISO 222, and it goes to asynchronous FSP API, for example, or any other version of an API that we can have in parallel eventually. So that's just an important note. When can you use it? Because that was the question that you wanted. So this is the promised roadmap. And we're here. We're on the alpha release target. This is what we promised. By Q2 this year, we would release an alpha. And we are releasing the alpha. True to our words, the team has made it, and you can actually test it now. There's two ways of testing. There's the excellent Miniloop vNext from Tom. Tom Daly produced this. This is the most simple way of doing it. It's exactly the same logic of Miniloop, which is a couple of commands, and you have a vNext working in your machine, a vNext implementation working in your machine with everything that we have. This is really simple. This is probably what everyone should be testing. There's another part, there's another way of doing, which is the Docker Compose. It's a bit more hacky, it's a bit more tricky, but it allows more flexibility, obviously. This is mostly for developers who are interested in testing or running different parts at different versions and so on. So it's out. You can go there and you can try vNext already today. What is in the alpha release? All of the happy paths and most of the non-happy path. This is important. There's still a couple of things that are not in there, but again, this is an alpha release. We need to always be reminded that this is alpha. It's not even a beta. So, but the functionality is pretty much all there. Does it work? I think we showed you last time Mojaloop vNext working against the TTK. This is the most recent feedback that we have. These are the most recent test runs that we had. And if you're not able to read correctly, in I don't know how many, 500 tests, something like that, we are failing 5. So we're going to get to 0. But a big shout out to the TTK team and Vijay and Miguel and Sam and all of those who contributed. This is an invaluable tool for us. How does it perform? We did run tests, performance tests. These are very early tests. This is alpha, so please keep your expectations in check. As usual, and this comes from the performance POC that we run some time ago, we did a 1-hour long test where it would only pass if only 1% or less was above 1 second. It's internal message-based tests with simulators, so it's not simulating all of the FSP IOP. So it's sending a message that triggers the prepare, triggers the fulfill, and then it does everything, and it measures the time that it takes from one part to the other. So it essentially tests the engine, not the car. It includes the logs, audits, security, and settlements. All of those things were enabled. There were no optimizations yet. We have the base part that does batching, but we don't have any performance optimizations yet. There's plenty of stuff that we need to do, including a lot of the things that Miguel and I came to the conclusion at the end of the performance POC that we should do. Some of those things were not done yet. So we're not trying to overly optimize yet because it's not needed. It's a single instance. So we're not running in a big cluster with a lot of instances. We have one instance for transfers, we have one instance for participants, one instance for the ledgers, etc. And we're using the built-in ledger implementation. which is admittedly something that is not supposed to perform, because if you want performance, you need to use the Tiger Beetle ledger implementation, which you can. It's a choice in vNext. And it did this. So one instance with just one instance of each service in a very small environment did 100 transfers per second, and it did 500 lookups per second. And all of this with no errors and within 1 second response time. The lookups we did with the get party and the get participant, they were a mix. So this is the minimum that we are getting out of vNext Alpha. This is not yet scaling and testing powerful machines and testing. This is the minimum that we are getting. And this is
and Pedro, is this essentially one pair of DFSPs?
It's one pair of FSPs, yes.
So this is, just so people know, the last time we did this, we scaled it up to many dozens of DFSPs. What we found is that we essentially topped out around 25 TPS per DFSP. So we're already, without even looking at performance yet, or any of the work that will be done to make this ready for release, we're already 4x on the previous code base at the time at which we initiated this activity. Now, that code base has also moved forward since then. So the targets are moving. But what we had set ourselves as the goal with the vNext project was to markedly improve the performance and scalability of the system from the beginning. And so at base scale, saying this is just a test environment and it's not optimized, that we're already above the baseline, if you will, for single instance performance that we had before is pretty good. That's a great baseline to start from. So congratulations on that.
Thank you. And yes, you're right. And this was just because it was just with 2 participants. There's an effect to that will probably multiply it. But again, this is alpha. We really hope to have better numbers for you all next time. And we didn't test the quotes because we are assuming the quotes are very similar to the transfers. So in the way they work with 2 legs and the going back and forth. So we didn't test the quotes, but we are assuming it's going to be around the same performance as the transfers. And again, this is not yet optimized. There's a lot of things that we can do to get better numbers, and we're not using Tiger Beetle. So Tiger Beetle will make this go much faster. This is a.
Can I just ask Pedro? What is the implementation of the ledger right now? Is it a SQL database?
It's a MongoDB database.
MongoDB. Okay. Okay. Understood. So these weren't end-to-end tests, right? Was it TTK you had on one end as a simulator, sending and receiving to another TTK on the other end? Was it kind of an end-to-end scenario?
It was just messages on the inside. So if what happens is we send a message that is the same message that the FSP IOP sends when it receives a request to do a transfer. So the process is you request an HTTP transfer, and that gets transformed in a message that goes to Kafka. We send that message internally, and then the message is processed. The prepare happens. It goes to the ledger, does the liquidity check, does the reservation, and then it comes back to go to the payee so that the payee can commit that to a message again. So again, what we do is we are listening to that message that goes out to the payee, and we are responding with a message that's equivalent to the one that the payee sends, saying, yes, I want to commit this transfer. And then we measure.
So, okay. I'm just trying to get in my head an understanding of a couple of things. The liquidity check. Were you performing the liquidity check on each one of these transfers? And was that against a number that was in memory only, or was that number disk backed?
Everything is being stored. It's since the way this works is in batches, so that we can fail a transfer. So we have 10 transfers that go in. Those 10 transfers are processed in sequence, and then at the end, they're all committed, or none of it gets committed, or they fail. So the way it works is at the end of a batch, we flush. It's exactly like Tiger Beetle works. Essentially, we're not reinventing the wheel, neither is the Tiger Beetle team. But the way it works is like this. We process a batch, we flush it to disk before we respond. So we only respond to the other system, in this case is the accounts and balances, only responds to the check liquidity and reserve command if it's stored in disk. And then we respond and say, yes, these 10 were performed. There was one that failed because there was no liquidity, but it's stored. And then the next one picks up the batch and does exactly the same thing.
So do all the other transfers in that batch then fail if one fails? Would the initiating DFSP have to resend those transfers?
No, they are independent. We are just batching in units of work, but the units of work they are applied in sequence, and they can fail independently. And we can optimize the batching mechanism.
One of the fundamental bottlenecks with vNow was the fact that we had to continuously update the liquidity balance in a DBMS on disk to be resilient to any failure, any power outage, and to be able to recover at that exact point in time. Am I right that you are doing the same thing?
I'm achieving the same effect. Let's put it this way. What we do is we get 10 transfers. We get 10 requests, a batch. Let's call it a batch. We process that batch. We get the data from the disk to process that batch. We process the batch in memory. We flush the result and we send it out. If it fails the flush, so if it fails to go to disk, the result is an error. So we don't store bad information. We don't respond without the guarantee that the data is stored. So effectively what we do is we do 10, for example, in memory, and then we store the result and we send back the message saying that those 10 were done or 5 were done or whatever. But if there's a technical failure, in the case of, for example, I'm not able to store that in my disk, then I'm going to reject that message, that whole batch, which means that to the transfers component, for example, that whole batch of messages, of requests was failed. So there's a message that goes back to the payer, for example, saying, well, there's a technical error, it didn't happen. What we are
to be clear to his question, the updating of the position and the testing of net debit cap and all of that is being done as the batch is being processed in an atomic fashion. And so an individual DFSP, any locking that might go on and other kinds of things, that is a consequence of the working with that batch individually. And so that's, I think, what the nature of the question was, and you might want to address that. How do we know that can we get a position at any time and know that it's correct? And does that create a bottleneck that, of course, becomes an issue for performance? I think we used Redis on the old system to minimize that.
It's the same. Whenever you request a position, there's only one system that's going to respond to you. So you always get the truth. Always.
So it's single threaded in that sense. Exactly, that if I have.
Exactly.
I have a series of messages that are batched up through different pods, and they're going to make a request. Each one of them has the same DFSP in it. So I might have 15 batches outstanding across a different set of pods. They all have to make the same updates and requests to that liquidity position in no guaranteed order. Of course, we've said you can't be guaranteed of sequencing on this system. So the updates will occur in whatever order they occur. But it is still single threaded through that Redis position database. Do I understand that correctly?
We're not using Redis, but yes, the sequencing is guaranteed inside the system. So if you send 10 requests, those 10 requests will be performed in sequence, which means that if the 11th request was give me the position of my liquidity account, for example, or my position account, then it gets processed after the other 10. So we guarantee that the ledger system, our accounts and balances is split in two parts. There's a chart of accounts, which is like a facade that allows us to have multiple or different ledgers. One is Tagabidal, the other one is what we call the built-in, which is what we used for these tests. And what happens is that we make sure that everything that goes to the actual ledger goes in sequence in order of arrival to the chart of accounts system. So you can have as many as you want asking questions to that system. We guarantee it has the effect of a lock in that. It's like it's single thread, as you were saying. You can have as many going in batches, in gigantic batches. They are still processed. The first one will be processed always before the second request. And the second request, if that's a query, tell me my position, that's going to be the right position. You always get the right answer. You're not getting it from cache. You're not getting it from any other place than the source of truth of the system.
But again, from a scalability point of view, you're speaking in the abstract sense of interfaces between bounded contexts. I'm speaking about the pods. So if I have 15 different pods that are reading and processing batches, they could all have representation of the same DFSP, and so they will have to use locking on the database in some form so that they can ensure that their accesses to reading and updating that position is atomic. And of course, you can't determine the order in which those things occur because they're running concurrently.
We can use partitioning for that, but and that will solve the problem like we did for the performance POC.
Okay, just without going too far enough, we don't care what order they go in. We're not making any guarantee to anyone on the outside world.
That makes it a lot easier.
Yeah, that's basically what we're saying is that you can't guarantee the order because we're scaling this thing horizontally. Concurrency works the way it does. And assume that if you put it in, we won't lose it and we will process it correctly. But the order in which they're processed can't be guaranteed. So, for example, if your particular transfer request would fail if it came after another one, then whether it succeeds or not is a matter of somewhat random access. You can't guarantee that. So in other words, if you say I'm proposing to do this, well, it has to be reserved. Then the reserve either succeeds or fails. If the reserve succeeds, then you're in and you will guarantee that transaction will go through. If your reserve fails, then you're aborted. And if the order in which you either succeed or fail is dependent upon you being very close to the edge on a balance, we're not going to make a guarantee to you as to whether it succeeds or not based on timing. I don't think we have to do that. But somebody could correct me if they believe it's different. But
so you just multiply the performance by 5 or 10.
Right. That was the idea.
One further clarification. One further clarification, if I may. If you have multiple instances of that pod, each trying to service the same DFSP, you will have to use a distributed lock on the NDC on the position, correct?
Yes, but guys, there's a point that matters here. We are using the built-in ledger implementation, which is not supposed to scale like mad or perform. What I'm giving you is a flavor of, with the worst technology that we have, you're going to get. You take out the built-in ledger and you put Tiger Beetle as a ledger, and this will fly. So I'm being conservative here. What I'm saying is, this is not the component, the ledger component that's meant to scale or to perform very much. Okay, that's important.
Okay.
That's fine.
Okay, thanks.
Right, but yes, Miller, you just made it go much faster. So
I mean, that was an original design consideration that was fairly quickly taken. I think it was the background for it was that if you allow people, banks in particular, to take advantage of this, they could choose to essentially fail as many payments as possible because they get paid, right? And we don't want them to arbitrage the system so they get paid fees by reordering the way in which they submit transactions, knowing those are guaranteed. We also don't want the switch to be on the hook of having to follow their rules directly on the sequencing and ordering of payments, because it's inherently a parallel problem. That's what we're trying to solve. Is for each DFSP, these payments appear to be processed in parallel in arbitrary order, and between DFSPs, they're processed concurrently towards the settlement batch. And going anything inside of that would essentially be taking the back off the watch and allowing people to watch the gears mesh and try to make some decisions based on that. And we don't want that. We want the flexibility to change the machinery inside the watch, and they have to essentially interact with the watch face.
Okay, that was good. Then this number is void. Ignore it. It's going to be much higher. So we will have news for you in the next demo, and hopefully it's a much nicer number.
Okay, Pedro, we're well over time now.
Oh yeah, sorry. I have
just one final question for you. One final point. First, congratulations to you and the team. You've done a tremendous job here. It's really impressive, and we're all very excited about it. Just two comments about that. First of all, it's now reached a point at Alpha where the product team need to have a look at it. We need to go through and make sure that what's there is suitable and in place for a real operation in terms of the functionality available to hub operators, participants, etc. Secondly, at this stage, I think it's the right time to say that people within the foundation need to start doing an in-depth cross-cutting code review here to make sure that we're happy with it and start really checking that, really go around kicking the tires, make sure that we're happy with it. So that'll be happening.
Because now Miniloop now allows you.
Yeah, exactly. And I'll be using Miniloop, and I'll be going through doing my product review, and James and Sam will be going through their code review. So that's our next steps for us we're concerned. So thank you for
guys.
this. Great
well,
progress.
thank you. That's going to help.
Okay.
All right. So sorry, I need to wrap up, and I'm going to go as quick as possible. So this is what's missing from Alpha. The certificate and JWS validation. This is designed. Mind you, I don't want to scare people. It's not done because we didn't have time. It's designed for. Transfer timeouts. Again, this is designed. We already have the scheduling mechanism that allows us to send a message when timeouts happened. Bulk transfers is not there yet. Proper performance optimizations. There's none, basically. We're not using binary. We're still using JSON messages. We're not partitioning as we should. There's a lot of stuff that we can do. And we don't need to care about ordering, which is probably going to be the biggest performance boost. The customer notifications that I was mentioning, it's not yet implemented. There's more tests that are needed, code cleanup and better documentation. That's a constant of this effort. We're trying to set the tone on how to have CI/CD, code, tests, and code coverage and all of that in documentation. The other part that's missing is feedback, or more feedback from brave implementers willing to try it. We hope that now with Miniloop, people can test it really quickly on a VM and provide us feedback. Even if it's feedback, well, there's plenty of bugs probably that people need to help us catch. And there's going to be feedback about functionality and features and UI and user experience. We welcome all of that. We need it. Next steps. All we can do is propose a roadmap to production. And according to our cadence, what we can do is for the next quarters, incorporate feedback, work on the performance optimizations, the missing features, more tests, more documents, and then keep going. Just keep on doing it until we have a beta that is released. And then we keep on doing the same until we release a release candidate. So that's an intention. Hopefully we can get it as soon as possible. How do we work? We do fortnightly workshops every Thursday at 11 UTC. This has been going on. This is a serious, important aspect of our team collaboration and effort. Anyone can join. At these sessions, we show the code, we show the progress, we show what we're doing. It's like a sprint, not a sprint review, but it's like a sprint demo, and anyone can participate and help. It will be great if you guys can participate in some of these sessions and ask questions and point us in the right direction. For developers, we have the snapshot releases for Docker and Kubernetes already in GitHub. Non-developers already Miniloop, as I showed. This is the Slack channel that you can use to reach the team. And well, obviously, there's no space again to have the pictures of everyone, but this is the team. Our team has been great, and I'm the privileged one that can present this and be associated with this. But please mind you that behind me showing this, there's a big team working and putting a lot of hours and a lot of effort to this. With that, I conclude my presentation, but there's one thing more. I'd like to invite Hong to talk us about the experience that this work has been having in this process. So over to you, Hong.
Hey, thank you, Pedro. Since we are running out of time, I will be doing it really quickly. Okay, let me share my screen. Okay. I think I will use this screen instead of the presentation modes. Do you see my screen?
Yeah.
Okay. Recently, we performed this end-to-end testing in vNext. This is how we perform that end-to-end test. Basically, we try to use we try to use all the existing components as much as possible, except the Mojaloop core components. Because the reason is we want to test out whether vNext is compatible with existing components. So what we did is we removed the existing Mojaloop core component from existing our hub, and then we replaced with the vNext. Then we onboard the existing TFSP onto the vNext using the admin UI, then we perform the end-to-end testing, such as code, lookup, transfer, all these things, including the settlement thing. So it really impressed us. We can perform really well, and we also ran the load test. The result is also a really cool thing. So I can say vNext is really nice, and congratulations to Pedro.
And
maybe I think I can skip these slides because these are just the steps we have performed for this configurations. Okay, there is not much thing. So this is the roadmap we target. I think that one Pedro also shared. At the end of the June, we are doing the alpha release. For us, we already tried this alpha version in our existing hub, and at the end of the November or somewhere around in the November, we are targeted to release the MVP versions, and then maybe in somewhere in the next year or somewhere. So we are targeted to release the protection version. So this is the our experience in vNext. So that's all.
Thank you, Ong. And thank you, DissoWorks, for the help that you guys have been providing. I'd like to be very clear that it's not just developers and people working day to day, you're using it. And using it, it's probably the most valuable thing that we can have. So I encourage everyone else that is in the position of doing what DissoWorks is doing and trying to run their own vNext switch, please do that. We will help you as much as possible, and we are welcoming your feedback whenever you have it. Thank you, everyone, and again, thank you to everyone in the team for such great work.
Before you go,
can you just clarify, Pedro? You said it's being used by DissoWorks. In what context is it being used?
I let Ong respond that.
Sorry, pardon?
Are you using this in production to move real money, or are you testing and evaluating?
No, this is not in the production. This one we use in our development environment, but we use the TFSP, our demo wallet, which is demo TFSP. We can simulate the end. Yeah.
Okay, that makes sense. Thank you.
Yes.
Thank you so much, Ong. Thank you so much, Pedro. This brings us to the end of today. I know those of you who are looking at your agenda and saying no. We've decided to move the last session. Sam has graciously allowed us to move that to tomorrow. That's a core team and documentation update. So we'll start with that session first thing tomorrow morning at 11 a.m. UTC. And then tomorrow is, after Sam's core team update, we'll have a session led by Paul Macon, which James Bush insisted on the first day that we need to pay attention to. I need to emphasize again, we make decisions here. So, and the people who make decisions are the folks that show up. So tomorrow is decision-making day. One of the, some of you might have seen a workstream governance document going around. You might want to read that before the meeting tomorrow. And we will decide again what work streams we will have and will be supported by Foundation in the next PI. So please be here tomorrow morning. Well, it's not morning for everyone, but tomorrow 11 a.m. UTC, whatever time that is for you. And we have a pretty packed day tomorrow. Please be ready to make your pictures and advocate for the things that you need to do, and we will see you then. Thank you so much for joining us, everyone. Have a good rest of your day.